energy. Charge yourself up because a lot is happening here at the second edition of Economic Times Smart Manufacturing Virtual Summit. 3 done and a lot more to go. And a lot with something very special starting right away. Well, becoming Uber and Uberizing is the thought, but how about we Uberize the smart manufacturing? Yes. Think about it. As you think about it, I'm going to give you someone who's going to address all your thoughts, all your questions into a perfect, insightful session. Joining us all the way from US right now, the midtime, but here in the afternoon in India, please welcome Sundi Raman, Head of Digital Products and IoT, Airtel Business, here at the second edition of Economic Times Smart Manufacturing Virtual Summit with a virtual round of applause. Hi, Sundi. Good afternoon in India and a good evening to you back in US.
Thanks, Mithun. I'm absolutely delighted to be part of this session and thank you for giving the opportunity to share my thoughts around smart manufacturing and what it can do for an industry which is set to transform a lot of products that we are going to use in future. And so absolutely delighted about this. So as Mithun introduced, I am Sundi Raman. I head the product at Airtel Business. So I wanted to take time today and talk about smart manufacturing and its impact, and more importantly, how 5G as a technology can unlock the demand or the dormant demand that is there in the manufacturing sector for them to transform themselves. So before we go into the deep dive into some of the essence of what is 5G and what it can do, we just want to take a moment and talk about the 3 goals the enterprises are trying to go after right now. I don't think there's any surprises here, but it's good to acknowledge because this will actually be the guiding force for what we want to achieve for these enterprises from a technology standpoint. The first one is, of course, improve the business agility. That is faster time to market, provide first time right products, and create a separation for them with their competition, right? It's trying to grow the revenues. Second is driving operational efficiency, which is around reducing the cost to serve while not compromising on the quality or the experience. Third one, which is around digital transformation. This is around how they actually connect with their customers, not through only physical medium like a store, but also through digital touch points, right from the time they want to acquire their customers all the way down to how they want to serve. So digital transformation is one of the key goals of an enterprise today. Now let's take an example. I want to take an example of Kriloskar to actually make it more tangible for what we talked about in terms of the business goals. So Kriloskar, as you may know, is widely well known in terms of genset manufacturers, one of the largest in India. They actually wanted to monitor their gensets that are being used by their customers, and the simple reason for that is they actually wanted to improve the experience in terms of reducing product fault rates, and even if there's an issue in the field, how they actually resolve it as soon as possible, and try to give transparency into the performance of their gensets, which will drive stickiness with their customers. Now, at this point, they had no visibility. So what they did was they embraced the technology called IoT, which has a lot of different pieces to it. The first piece is, of course, you have to put a sensor here to collect the data. So they did that. Then they connected it back over the cellular technology because that is the best way to do it, because these gensets can be anywhere deployed. So ubiquitous connectivity was very important for them. And then finally, they took all this data and then processed this in their cloud. So they made a physical object live, or you can say they created a digital version of their physical object. This allowed them to do a few things, which is they were able to tell their customers how the genset was performing. That's the number one thing. Second, they were able to collect this data and also to predict if there will be a genset failure. Now, this is very important because many of the gensets are driving business critical processes for their customers. So for them, the ability to predict failures and then take care of it before it happens is very important. Finally, even if the issue happens, how soon they were able to resolve is a very important part of it. So with this solution that they have today, they have saw some dramatic shifts in their business goals. One is they were able to reduce 25% in terms of mean time to resolve of their equipment failures, 30% reduction in warranty costs. Now that is where it goes right to the bottom line. So what through this story, what I'm trying to convey here is the technology can be a big enabler to achieving your business goals, like Kriloskar is trying to do. Now, what if we do this across the life cycle of a product? We looked at Kriloskar as an example where they were trying to do post-sales improvement and trying to improve the business efficiency around that. What if every part of your product life cycle you're able to achieve superior business efficiency? So in the design stage, can you actually prototype your products faster? Can you reduce cost of prototyping? Second, when you're manufacturing your products, are you able to maximize your OEE metric, which is your overall equipment effectiveness? How can you improve that? Third, when you're delivering or installing your equipment, how can you do it at scale? And finally, we saw how Kriloskar was trying to do it for their post-sales, which is maintaining it, which the data you collect from the maintenance can be fed back to your design stage to improve. So the answer to this is what we call the mirrored world. It's the digital twin version. It's a digital twin, which is basically you take the physical object, you create an avatar of it in the digital world. Now, what can it do for you? If you're in the digital world, I take an analogy in the software world. Like I come from a software background. So we are used to actually doing faster prototyping before we actually release the software code. In this case, we are taking the physical object, giving a digital version of it. Now, an engineer can actually, in the design phase, do faster prototyping and place some variables of environments to see how the prototype will actually react, and whether there is better efficiency to be gained with some of the tweaks they're trying to do in the design. Secondly, if your manufacturing plant is actually digitized, that is, you have a replica of it in the digital world, you can figure out ways to improve the OEE metric very easily and try to maximize the usage of your plant. Now, in the delivery stage, because you have a digital version of the physical object, you can use augmented reality ways to get your field engineers to deploy it at much faster clip. You can actually have your workforce up and running and trained much more easily to scale your business in terms of your delivering it at the right time. Finally, as we saw with the example of a Kriloskar, you collect this data, you are actually able to predict failures, you are actually able to do proactive maintenance. And not only that, the data you're collecting by the field usage, your equipment being used by your customers, you can actually feed that back into a design stage, again, in the digital world, and try to see whether you can improve your product. So this is a virtuous cycle you can create if there is a digital avatar of the physical asset that you're selling. And truly, if we achieve this goal, the manufacturing industry will be can be in a different phase of their innovation cycle. Now, what are the mirrored world enablers? I boil it down to three things that needs to happen for this the mirrored world to make a reality out of it. One is the ability to sense, lots of sensors to actually measure every aspect of the physical asset to create a very accurate digital twin. So thousands of sensors maybe to measure every aspect of your physical asset. Second is these sensors need to be connected, and this connection should be ubiquitous, ultra low latency and high reliability, because you don't want to miss the data that is being sent to the cloud for you to analyze, which is the third part of it. And in this third part, there's edge and cloud compute, along with the ability to integrate with industrial applications. So these three are the ingredients to actually making the mirror world a reality. Today, many manufacturers are on this path. Some are doing it, but there are these requirements that we talked about. And if you look at the requirement of connectivity, it's very super critical for this to happen because data has to be collected, sent somewhere reliably at very low latency for some of these factory floor automation to take place, some of the maintenance breakdowns to move to more predictive maintenance, and in a design phase specifically. So when we say 5G uberizes smart manufacturing, 5G provides the key ingredients here in terms of the connectivity layer, which we saw before, how critical it is to get the data from the sensors and use that to analyze and then drive the efficiency we're looking for. Latency wise, it's near instant delivery of data. It will be one of the latency will be less than few milliseconds when the data is captured anywhere and sent to a cloud anywhere. Capacity, again, we talked about if you have to create an accurate picture of the physical asset, you need to put a lot of sensors there to collect the data. So 5G has the capacity, will allow you to connect lots of millions of the sensors seamlessly back to your cloud. Finally, reliability. 5G will offer the fine line reliability for mission critical applications where failure is not tolerated. Now, once you have such a ubiquitous, low latency, high reliability connectivity, what creative minds can do is only a matter of time. The unique capabilities will unlock applications that never have been previously existed, or at least not to the same degree. And that's why we believe very strongly that 5G is going to be the Uber for the manufacturing sector. That is, it will allow people to bring their creative minds, develop applications, create digital twins version of the physical asset, innovate on the digital twin, reduce time to market, create first time right products, provide the right experience to their end customers so that they create separation in the market from the competition. With that, I'd like to thank you for giving me this opportunity to share my thoughts.
Thank you. Thank you so much again. A big round of applause for Sundi Raman. They're joining us live and talking to us urbanizing much more. Thank you again, Sundi, for joining us here this afternoon. And I wish you great luck in the coming days. And also be safe wherever you are.
Thank you.
All right. To others who are watching us, that was again a very interesting, very insightful session. I want to thank our partners, title sponsor partner, Dell Technologies, co-powered by partner NTT Data, trusted global innovator, energy efficiency partner, ABB, gold partner, PTC, associate partners, Microsoft, Accenture, Airtel Business, Hexagon, knowledge partner, Deloitte, media partners, Mechanist, engineering review, and OEM update. All right, we get set for the next session very quickly. In the meantime, what you can do is go visit our partners experience zone, seek more, learn more from them, and get one-to-one chat. And we're here getting ready for our next session. Look at it, what is coming up next.